Greetings and welcome to another installment of QuantSlob. This is 12 in our foundational series. This time around, we're going to take a peek at two very commonly used measures in data science, the proportion and the average. And we're going to do this with a little bit of formality. Proportions, I think, are fairly intuitive, at least for small collections of objects. In this particular example, let's suppose we have a population of 3 fruit, and we have an attribute simply type of fruit. And we see here we have 2 apples and an orange. So what is the proportion of apples within this population? There's a total of 3 elements here. 2 of them are apples, and therefore our proportion would be 2/3. Fairly intuitive. Most of us can do it off the top of our head. What we're going to do is we're going to introduce a little bit of formality here. We're going to start by fashioning a type of indicator function. We call this function f. This function takes 2 inputs, x and a. If x equals a, the function is going to return a value of 1. Otherwise, it's going to return a value of 0. And our proportion then ultimately is going to be equal to the number of times x equals a divided by the total number of elements. So here's a detail of this calculation. And you can see that there's sort of sprawling. We've expanded out the summation. And if we don't like looking at this, we can sort of change the order of how we advanced our calculation here. We can take our indicator function f and apply it directly to the population elements here and input the attribute type of fruit. So the value returned by our function simply becomes an attribute of our population elements or members. This makes the subsequent calculation of our proportion of apples much cleaner and easier to look at. So moving on, let's take a look at average. Same population, 3 fruit. Average is a property of a quantitative value. So let's consider the mass of our fruit. How do we calculate the average mass of our fruit? Here's a very common and straightforward way to calculate an average. This looks similar to what we just saw with proportions. The denominator, the part on the bottom of the fraction, is the same. The numerator is a little bit different, the part on the top of the fraction. Instead of summing over the indicators like we did with proportion here, we're just going to sum over the individual quantities. So no problem, let's perform the calculation. We've got 92 grams plus 95 grams plus 101 grams equals 288 grams divided by 3. We get our answer here, 96 grams. Notice that the average preserves the units of our attributes. A couple things before we sign off here. From a computational perspective, we do not imagine ourselves recursively summing over an infinite collection of quantities. So I think it's natural for us to imagine in the preceding calculations that we're restricted to solving our proportion or average over a finite number of population elements. However, it should be said that mathematics does allow for summing over an infinite collection. There are other ways, finally, to calculate an average. I particularly like the argmin of a sum of squares. And that's it. That's going to do it this time around. Thank you very much for tuning in. I really do appreciate it. And don't forget to stay tuned for more QuantSlob.